welcome to my tutorial video. And today we are going to be talking about complex variables in Maths 305. And first we are going to consider the first subtopic there, functions of complex variable, and it is given as W equals f of z, where z equals x plus iy, and z is a complex number given by x plus iy, where x is the real part, iy is the imaginary part. So suppose we have f of z equals z squared. We are simply going to put in the complex number x plus iy, then square it. So we are going to have x plus iy all squared, and this will give us, if you open the bracket, you are going to have x squared minus y squared plus 2ixy. If you check this carefully, you are going to see that x squared minus y squared is the real part because it is not multiplying by I, and also 2ixy is the imaginary part because we have I there. But don't forget that I is equal to the square root of minus 1. So from here, we are going to see that x squared minus y squared is the real part, 2ixy is the imaginary part. So let's define another variable that will tell us our real and imaginary parts. Suppose we define x squared minus y squared as the real part as u of x and y, because u here, which is x squared and y squared, is a function of x and y. It contains both x and y as the variable. Plus, I'm going to bring out iv of x and y, because it also contains x and y as the variable there. So since we have come to know that f of z is now equal to u of x and y plus iv of x and y, u of x and y plus iv of x and y, where u of x and y is the real part and iv of x and y are also, iv of x and y is the imaginary part. So since we have understand functions of complex variable, we are going to consider the first question. So let's take down this question. Determine the locus represented by z, the magnitude of z minus 4 equals to 6, and b, the magnitude of z plus 4 equals the magnitude of z minus 3. So I'm going to take the first one. A, the magnitude of z minus 4 equals to 6. First of all, recall that you know that z is equal to x plus iy. So you are simply going to put this complex number z equals x plus iy into this function. So we have the magnitude of x plus iy minus 4 equals to 6. And to simplify any given magnitude, you simply take the square of the square root of that function or number. So it means that, well, first, before we take the magnitude, let's first of all separate the real part from the imaginary part. So separating the real part from the imaginary part, we are going to have the magnitude of x minus 4 plus iy equals 6. X minus 4 plus iy equals 6. Then let's go ahead and take the magnitude. And please take note, whenever you are taking the magnitude, you are not going to square I, because I here is just imaginary. You are not squaring I. So you are going to have the square root of the real part, x minus 4 all squared plus the imaginary part, which is y squared, and this is equal to 6. So now Of course, we know to further evaluate this or to remove this square root, we have to square both sides. So squaring both sides, if you square both sides, you are going to see that the square is going to cancel out the square root, and then you are going to have 6 square here. So this means that we are going to have x minus 4 all squared plus y squared equals to 6 squared. If you look at this carefully, you are going to see that this is the same thing as the equation of the circle. Recall that the circle equation, recall that the circle equation is given by x minus a all squared plus y minus b all squared equals r squared. So if you compare these two things, you are going to see that a is 4, b is 0, because we don't have any point here. So it simply means that our b from here is 0 and r is 6. So it means that this given question, the magnitude of z minus 4 equal to 6, is simply a circle centered at 2 points A and B with radius r. So thus, the magnitude of z minus 4 equal to 6 is a circle centered at 4 and 0 with a radius 6. So we are going to move on to the next one. The magnitude of z plus 1 equals the magnitude of z minus 3. We have the magnitude of z plus 1 equals the magnitude of z minus 3. So the same process we used in the first one, we are also going to use that same process. So we have, first of all, we are going to put in the value for z in the left and right, the left hand side and the right hand side. So this means that we are going to have x plus iy plus 1 equals to the magnitude of x plus iy minus 3. So the same process, we are going to separate the real and imaginary part. So this means that we are going to have x plus 1 plus iy equal to the magnitude of x minus 3 plus iy. So also, to simplify this magnitude, we are simply going to take the square of the square root of the real and imaginary parts. So this means that we are going to have the square root of x plus 1 all squared plus y squared, and this is equal to the square root of x minus 3 all squared plus y squared. So this is what we are going to have. And for us to be able to further simplify this, we have to square both sides to eliminate the square root. So squaring both sides, if we square both sides to eliminate the square root, we are going to have x plus 1 all squared plus y squared equals x minus 3 all squared plus y squared. So let's continue. We have x plus 1 all squared plus y squared equals x minus 3 all squared plus y squared. So let's open this bracket. To open this bracket, we are going to have x plus 1 multiplying x plus 1 plus y squared equal to x minus 3 multiplying x minus 3 plus y squared. So multiply this out, we are going to have x times x, we are going to have x squared plus x plus 1 plus y squared equal to x squared minus 3x plus 9 plus y squared. So this means that we have x squared plus 2x plus 1 plus y squared equal to x squared minus 9x, x squared minus 6x plus 9 plus y squared. So let's bring all what we have to the right hand side, to the left hand side, and then set it to be equal to 0, because we are trying to find the coordinates of either x or y. So this means that we are going to have x squared plus 2x plus 1 plus y squared. If this crosses to the other side, it becomes minus x squared plus 6x minus 9 minus y squared equals to 0. So it means that x squared, we cancel minus x squared, and we have y squared, we cancel minus y squared. So we are going to have 2x plus 6x, and this will give us 8x. So we have 8x equals 1 minus 9, and this will give us minus 8, and this will give us minus 8, and this is equal to 0. So it means that 8x is equal to 8. This implies that x is equal to 1. So from the question where we have the magnitude of z plus 1 equals the magnitude of z minus 3, this leaves us with x equal to 1. It means that it is a vertical straight line intercepting the x-axis at 1. It means that we have a vertical straight line intercepting the x-axis at 1. So this means that thus x equal to 1 is a vertical straight line intercepting the x-axis at 1. So thank you for watching this video. In the next video, we are going to talk about the derivative, and we are also going to move on to analytic functions, still under complex variable. Please like, share, and subscribe.